Hi everyone. Okay.
Hi.
We are going to start our presentation with introduce ourselves first. So my name is Nurul Atira binti Yusni, and my matric number is 207701. I am from Bachelor of Science Chemistry. Next.
Assalamualaikum. My name is Nur Ain Shamila binti Kamal Arifin with matrix number 207777, and I'm a student from Bachelor Science of Chemistry. Okay, thank you.
Okay, Assalamualaikum and hi. My name is Balikis binti Ismail Rani. My metric number is 207782 and I'm from Bachelor of Instrumentation Science.
Hi,
So
my name
next.
is Nur Sabrina binti Mama Amin. My trade number is 207649. I'm from major in pure chemistry. Thank you.
Okay, hi and assalamualaikum everyone. My name is Nur Ain Arisha binti Azami and my metric number is 207895 and I major in Bachelor Petroleum Chemistry.
Okay, hi everyone. My name is Fatin Shaira binti Shabudin. My metric number is 207773 and I'm taking Bachelor in Chemistry with Education.
Hello everyone, my name is Muhammad Adam Bezikiti. My matrix number is 207827. I'm from Bachelor of Science in Major in Chemistry with Honor.
Okay. Can we start our presentation? Yes. Okay.
How to find optimization? So firstly, after you read the question, you try to apply all the information given by drawing a picture first to visualize the idea of optimization. And if the question is about cylinder, then you draw the cylinder. Next, you find an equation formula that related to the variables. If the question asking you about volume, then you write the volume formula. Next, you rearrange the equation into one variable to find the unknown dimension that been asked. Normally, one value will be given either area or volume. And the last step is you maximize or minimize the function by first derivative. Locate the maximum and minimize, locate the maximum or minimum value of the function. And this step typically involves a function, typically involves looking for critical points and evaluating a function at endpoints. So let's try to apply this step into our question 8. So I will pass my presentation to Balkis.
Okay, so for this question, so the top and bottom margins of a poster are each 5 centimeters and the side margins are each 3 centimeters. If the area for printed material on the poster is fixed at 360 square centimeters, find the dimensions of the poster with the smallest area. Okay, from the slide before, we knew that we need to visualize the picture. So we have this square with 360 square centimeters. And the second one, we need to create the variable equation. So the area of the square is x multiplied by y, which is the length of the printed area and the width of the printed area. So from the question given, we knew that the area of the square and are 360. So we will continue for the next one.
Okay, thank you, Balkis. So I will proceed with the next step. Okay, as Balkis mentioned before, the x and y is referring, x is referring to the length of the printable area and y is referring to the width of the printable area. Okay, whenever we deal with the two difference, as we all know that x and y are two different variables. So whenever we deal with the two different variables, we have to make either x or y as a subject. So we're gonna make y as a subject and move the x values to the right side, and the equation would be y equals to 360 divided by x. So it would be much more easier for us to compute and substitute for the next equation. Okay, I'm done with this part. Okay, next moving on to the second part, which is rewrite the equation into one variable. Okay, as we can see that they have stated that x plus 6 and y plus 10. Okay, from where the 6 and 10 come from? Okay, we can see clearly from this diagram. Okay, we knew that x is referring to the length of the printable area. So we have to find the actual printable area. Okay, thank you, Adam. X plus 6 come from x this part and 3 and this would be x plus 3 plus 3, and we'll sum up to x plus 6. Got it? And then same goes to the y plus 10 also. Why you want to find the value of the width, and then we have to sum up with the 5 plus 5 plus y, and it will be y plus 10. Okay, so clearly we can show and prove that a equals to x plus 6 and y plus 10. Okay, first thing first, we notice that y is a different terms, right? So we already make it y as a subject from the equation above, which is 360 divided by x, and then we just substitute from the y here, and then we're going to continue with the multiplication step, which is the equation would be a equals to 420 plus 10x plus 2160 divided by x. So I think that's all from my part. We will pass to Ain Arisha. Thank you.
Okay, next I will be explaining for the next step. After we're getting the equation just now, and then we need to use the first derivative test in order to determine whether the critical number or the critical point is maximum, minimum, or neither. So first thing first, to make things simpler for us, we need to eliminate the fraction from the equation. Therefore, we need to bring up the denominator x and becomes x power of -1. And then we can proceed to the first derivative test. We can derive it as usual, and the final answer that we get is 10 minus 2160x to the power of -2. After that, we need to determine or find out the critical number by equalizing the first derivative test equals to 0. Okay, we got just now 10 minus 2160 x to the power of -2, and then we equalize it to 0. After that, we factorize it all until we get the value of x. The value of x that we got here are -6 square root 6 and also +6 square root 6. However, we don't choose both of it. We only take one, which is the positive one. Why? Because it is impossible for the printed area to become negative. So we choose the positive one to determine the minimum or maximum critical point. So we choose the +6 square root 6. So we make this table so that we can do two intervals, which is the left part is for the lesser value than 6 square root 6, and the right part is a greater value than the 6 square root 6. So we can put any value, so I choose 0 and 20 here. So after substituting 0 and 20 into the first derivative equation, I get it negative sign. giving the means of decreasing. And for the positive 20, I get it positive sign giving the means of increasing. So when the sign is first decreasing and then increasing, it gives the means of the critical number is actually minimum. See, so that's all from me.
Okay, now let's we continue to solving this problem. Okay, first we want to find the value of y because we already get the value of x just now, which is our x is equals to 6 set 6. Okay. When we want to find the value of y, we take the equation earlier, which is y equals to 316 divided by x. We substitute the value of x, 6 into the y equation, which is we get the y equals to 316 divided by 6 set 6. And we get the value of y is 10 set 6. Okay, next we want to find the length and the width. We know that the length we are equals to x plus 6. So the value of x that we get is 6 set 6 plus width 6. And for the width, we get we equals to y plus 10. And we get just now the value of y is 10 set 6 plus 10. Okay, now let's move on to next.
Okay, thank you. Next, what happens if we take value of x, negative 6, square root of 6? First, find the value of y. When x equal to negative 6, square root of 6, y equal to 360 over x. Then we substitute this value into this unknown of x, and we got the value of 360 square root divided by negative 6, square root of 6, and the final answer will be negative 10 square root of 6. Next, we want to find length and width. So length is x plus 6. Just now we got the value of negative 6 plus 6. We substitute into here x plus 6. Then the answer will be negative 6 square of 6 plus 6. And for width, y plus 10. So the value of y is negative 10 square root of 6. And we substitute negative 10 square root of 6 and plus 10. And now we can see that we got the negative value for the length and width. So it's possible to have a negative length and width. This is because length and width is a scalar quantity. Scalar quantity only have a magnitude without a direction. Direction is illustrated by the positive sign and negative sign. So next is about the area. So only area that measured by integration that can have positive and negative sign. So in this question, we only do a differentiation. So how can integration we get the value of negative sign? For example, if the area that we want to integrate is below x-axis, and above the area, and this area inside this is a negative sign. We get the negative value. That's all for me. Thank you.
Okay, now I will conclude this question. From this question, we able to find a function that we want to optimize. And then we also able to get the minimized critical number by first derivative test. After that, we able to differentiate the optimization function. And we also able to get value of x and y of printed poster. The value of x for this question is 6 square root of 6, and the value of y is 10 square root of 6. And then finally, we able to find the dimension of the poster, the length and the width of the poster as shown on this slide. The length is 6 square root 6 plus 6, and then the width is 10 square root 6 plus 10. I think that's all from our presentation. Thank you all.